Good day, everyone. Today on the Infinops Insights channel, we will be talking about all main Google Cloud Platform services. Google Cloud is one of the top three major cloud providers alongside Amazon and Microsoft Azure, so it's definitely worth exploring. By the way, you can also find videos on AWS and Azure topics on our channel. My name is Mark, and today we will provide an overview of the primary Google Cloud Platform services on the Infinops Insights channel. This will be the first part of our review of all the features of Google Cloud Platform. The initial video was very large, a lot of different information and insights, so we split the video into two parts. Please subscribe and hit the like button. Let's get started. Let's start by demystifying what GCP or Google Cloud Platform really is. It allows you to manage vast amounts of data, stream video content seamlessly across the globe, and harness the power of artificial intelligence and machine learning to innovate and solve complex problems. That is GCP in a nutshell. As a leading public cloud vendor, Google Cloud Platform equips you with an array of computing services designed to tackle everything from basic to the most advanced technological needs. Now, let's talk about GCP Organizational Structure. At the very top, we have the domain serving as the main entry point for our client's organizational structure. Within this domain, there are projects, each containing its own set of resources tailored to specific needs. As we navigate through each level of the organization, we find that access rights can be finely tuned. However, precision in setting these permissions is crucial. Permissions are hierarchical. Thus, some can inadvertently override resource-specific permissions, leading to common misconfigurations. This results in certain functions having more access than necessary, which we must diligently avoid. Well, let's look at how this structure is typically set up for our clients. The main organization account is anchored in Google Workspace and branches out into multiple projects, organized within separate folders. This structure not only ensures a clean segregation of resources, but also allows for streamlined permission management across the organization. And there you can see all the main GCP services. The first one is compute to launch and run applications in the cloud with scalable virtual machines and serverless environments. Next, storage and database. Fast NoSQL databases for all your storage needs with options for hot and cold data. Networking is the backbone that supports compute and storage, ensuring global connectivity and internet access, and big data to process large data sets and integrating them with other services to extract valuable insights. Others are developer tools, a suite of tools to manage account lifecycle and development workflows. Identity and security to save your operations from bots, internal threats, and guiding on best practices for project creation. Internet of Things to connect and manage your IoT devices with tools for real time data processing, cloud AI, machine learning, and AI services, management tools to oversee your projects with analytics and tools, data transfer. It's crucial to know that transferring data, even within the same project, incurs costs. Awareness is key to managing your budget effectively. Each level of the organization can customize its access rights, but remember, proper configuration is vital. Missteps here can lead to overprivileged functions, a common error that can compromise both security and cost control. Well, let's move on to the key component of management, IAM and Admin. It gives us full control over who and how can interact with our cloud resources. Here, we define who has access to our project and resources, manage roles, and privileges. Using access management tools, we can precisely see who has access to which resources, as well as ensure that each user has only the rights they truly need, and nothing more. Additionally, service accounts play a key role in automation and ensure the operation of our services without constant user intervention. They are like invisible assistants performing tasks behind the scenes. It's also worth mentioning the quota list, which shows us the limits and percentage of resource usage, allowing us to efficiently manage expenses and scalability. And if login is enabled, we gain access to the login history for each service, providing us with a detailed picture of our resource usage and helping to identify unusual or unauthorized actions. Finally, let's talk about user groups and roles. Creating groups with specific roles and access boundaries simplifies its user management, makes the process more scalable, and increases the overall security level of the system. Now let's switch to API and services. This is the control center for all APIs connected to your project. Here you'll find not just a list of available APIs, but also the ability to monitor their usage, including statistics on requests and quotas, as well as configure additional parameters. When entering the marketplace, we see over 400 projects, and many of them, such as Compute Engine, are not connected by default. This is an important point because before activating a service, you must fully understand its costs and limits. It's important to understand the impact of each connected API on the overall architecture of your project and budget. Each API brings a certain value but also incurs costs, so the key to success is finding a balance between functionality and economic efficiency. Next, let's touch on billing. This section, as you can see on the diagram, serves as your financial dashboard, where you can track expenses and resource usage within your organization. It's important to understand that access to this information is separate from standard IAM permissions. Access rights to the billing account are unique and managed separately, providing an additional level of security and control. Each project in your cloud can have its own billing account, allowing you to granularly and precisely configure budgeting and reporting. As you can see on the diagram, the entire hierarchy of resources from the organization to individual projects, virtual machines, and databases is closely linked to billing accounts. This allows you to have a clear understanding of the expenses generated by each element of your cloud infrastructure. Detailing down to the level of individual resource labels gives you a powerful tool for budget optimization. You can see where and how resources are being used most efficiently and where cost reductions are possible without sacrificing performance. On this slide, we are looking at key options: Compute Engine, Kubernetes Engine, Cloud Run, and Cloud Functions. Compute Engine will be used for traditional virtual machines. If you need a specific kernel, OS, special licensing requirements, or you want to migrate existing systems, this is your choice. You get full control and the ability to work with GPUs, TPUs, and a wide range of network protocols. For those working with containerization and aiming for modernization, Kubernetes Engine is the way to go. It is the standard for managing containerized applications, offering powerful tools for working with clusters and managing deployments. I will also mention Cloud Run, which provides fully managed infrastructure for running containers and cloud functions, designed for lightweight, event-driven code. Both of these services reduce operational overhead and offer pricing based on actual usage, making them also ideal for developers who want to focus on code rather than infrastructure. We will talk more about them in detail later. Moving on to the next aspect, let's discuss a bit further. A Docker image serves as the foundation for running code within a Docker container. Think of Docker images as a blueprint of a template for building Docker containers. Additionally, Docker images serve as the initial point of reference when working with Docker. You can link in an image to a snapshot in virtual machine environments. Compute Engine offers a variety of machine families optimized for different tasks, from general purpose to high performance computing and machines optimized for tasks requiring a large amount of memory. It's an ideal solution for hosting websites, running databases, monolithic applications, and containers, as well as working with Windows applications. Serverless functions often run on top of the infrastructure provided by Compute Engine, providing flexibility without the need to manage servers. Additionally, the system provides the ability to create snapshots for your disks and ensures high availability of your services through automatic backup capabilities and live migration. Let's not forget about GKE Autopilot, where you only pay for the resources actually used by your workloads, and Athons JKE, which is a set of tools for managing large container system. Compute Engine also includes a batch section for automatic or scheduled tasks, which, although a free API, tasks executed through it are billed at standard Compute Engine rates. All these capabilities are complemented by flexible pricing policies, including discounts for long term usage and prepared VMAs, which can significantly save costs for long term and stable operation of your project in the cloud. Cloud Run is essentially analogous to Lambda from AWS, but with some differences. The main one is that it's a Docker container. It allows you to run serverless code at a specific time or frequency and do something with the result, usually passing it to another GCP service. It allows putting a website or API or backend into a container which will scale depending on the number of requests. Interestingly, you can disable scale to zero because you can set it up so that at least one instance of the container is always on. By default, it has an HTTPS endpoint, unlike Lambda. App Engine is needed for hosting web applications or websites. You can host them completely serverless without local files with restrictions on power, volumes, etc. You can also host them inside a Docker container, which will be located in a virtual machine, compute engine of your choice. There is an option for local development through the appropriate SDK. And that's all. Thank you for watching the first part of our review of Google Cloud Platform features. The next part will be coming soon. Subscribe to the channel and turn on notifications. That way you won't miss the second part of our overview of all Google Cloud Platform features with insights on how to work with them. Like this video, share it with your colleagues and partners, and stay tuned. See you next time.